that we need to calculate the standard form of a parabola is the value of p. And so we have the formula a equals 1 over 4p. And obviously we've already calculated a. And so we can plug that into the formula. And then we need to solve for p, so we can multiply both sides of the equation by 4p, and then divide both sides of the equation by 4 times negative 50 divided by 46,617. And then we get this value for p. Now, of course, in the equation it says to put x minus h squared equals 4p y minus k. So then we multiply that by 4 and put that right here. So our final equation is x minus 251 squared, because this is representing the vertex, equals negative 46,616 divided by 50 times y minus 202.7, again representing the vertex. And then we can graph the equation, and this is the graph that we get. So this would represent the flight path of the ball. So now we need to find the highest point that the ball reached. And we saw from the graph that the highest point would be the vertex. So we've already calculated the vertex to be 251, 202.7. So thus, when the ball reaches its highest point, it's horizontally 251 feet from home plate, and vertically it's 202.7 feet up in the air. And here's a picture of Mickey Mantle, the person who hit the home run that we were just analyzing. So now we'll be moving on to the second problem. And you'll recall that it states that the second problem involves a ball that reached its highest point 204 feet from home plate, and it was 170 feet up in the air when it did so, and that can be represented as the point 204, 178. And because this is the highest point and it's a downward facing parabola, we know that this is the vertex of the parabola. And so that would represent the values of h and k in the standard form of a parabola. And so we can plug that in, and thus we get x minus 204 squared equals 4p times y minus 178. Now, in order to get an equation, we need to solve for p. And in order to do that, we need another point. However, we do have another point because we know that when the ball is first hit, it's at the origin, 0, 0. So this, we can plug in 0, 0 for the values of x and y, and then solve for p. So we plug that in, and we get negative 204 squared equals 4p times negative 178. And then we can divide both sides of, or we can simplify that, and then we solve for p, and we get p is approximately equal to negative 58.45. And thus the final equation is x minus 204 squared equals negative 233.80 times, because remember, again, we have to multiply by 4, times y minus 178. And so this is the flight path that the ball traveled. Now remember, the next thing we have to do is calculate whether that would have cleared the fence, which is 8 feet high and 399 feet away from home plate. So in order to do that, we can plug in 399 for x, because that's the distance from home plate, and from there we can calculate y to find how high the ball was. And if the ball is above 8, that means it would have cleared the fence, and if it's less than 8, it means that it wouldn't clear the fence. And of course, if it's a negative number, that means that by the time it's reached the fence, it's already bounced. Now obviously baseballs aren't actually going to go underground, they're going to hit the ground and bounce off. So we plug in 399 for x into the equation, and we get 38,025 equals negative 233.80 times y minus 178, and then we divide both sides of the equation by this and add 178 to both sides, and we get y equals 15.36. So obviously this is a greater value than 8, and so the ball would clear the wall by 7.36 feet. So that's all. Now it's important to keep in mind that for the purposes of these problems, I've assumed that the ball starts and ends at ground level. In some parts this wouldn't be the case, but for to keep these problems simple, we have assumed that that is so. And then here's my works cited. This gave me the information. These 3 sources gave me the information for the problems, and then this provided a graphing calculator, and then this provided helpful instructions on how to actually do the problems. Well, that's all. Thank you for watching the presentation, and I hope you've learned a little bit about how precalculus can be used in sports.